Alright, this is just some more table problems. This is question 4 on week 4, 5, 6. So we got this table problem that gives us results of a polygraph test. So it's really important that you understand how to read these tables. So this is, did the subject lie or not? No, the subject did not lie. Yes, the subject lied. Okay. And then over here, this is the results of the polygraph test. So positive test results indicate the subject lied. A negative says the subject did not lie. So it's really important that we understand where these numbers are coming from. Okay, so we can actually even understand what the question is asking us. So we're going to randomly select 4 of these people, these total, and without replacement, meaning after we select one, we don't put them back in. And we want to find the probability that in each case the polygraph indicated the subject lied. Okay, the polygraph indicated that the subject lied, not that the subject lied. The polygraph indicated the subject lied. Alright, look down here. The polygraph test indicated the subject lied. The polygraph test indicated the subject did not lie. We want the polygraph indicated the subject lied. So this is the people that we want. Alright, we don't want actual. We don't want whether they actually lied or didn't lie. We want the positive test results, basically. That probably maybe should have been worded. The polygraph had a positive test result. But anyway, the polygraph indicated the subject lied is what we're wanting. These two people, or these two numbers right here. So again, it's got the little box. So let's copy it into a table. We'll go over here and throw it into Excel. I think that's already it. Let me see. Yes, that was it. Okay. Anyway, I'm going to, just like we talked about before, you can highlight your cells and then come over here and click the sum button, and it'll add those rows and columns for you. So I'm going to put that there, put that there. Let's see if it'll do this. No. Alright, equals 79 plus 47. Alright, so there's 126 people here total, and the question asks us, again, find the probability in each of the 4 cases without replacement that all 4 ended up with a positive test result, or the polygraph indicated they lied. So that's, again, the total of these two, 1366, or the 79 total. So I'm going to do, this is the first person, the second person, the third, and the fourth. Alright, and then for this first person, what's the likelihood that they got a positive test result? So for the first person, there's 79 total people that had a positive test result out of the 126. Alright, and then because they're not replacing it, we're going to lose one. So there's no longer 79 people in there that had a positive test result. Now there's just 78, and there's only 125 left. And notice when I press the equal sign, it actually changes it to a decimal. But if I don't, it leaves it as the fraction. Alright, and so I just want you guys to see it. You don't have to do all this that I'm doing. I'm just wanting you to see where the stuff's coming from. And then the last one, 76 out of 123. Alright, so if you look up above, this is actually what we put in there. We put the equal sign in there to get the decimal. Alright, if you just write the fraction, there's the fraction. But I wanted you to see this is the first person, the likelihood the first person had a positive result. This is the likelihood the second person had the positive. This is the likelihood the third, and the likelihood the fourth. Now, what does the question ask? If 4 test subjects are randomly selected without replacement, find the probability that in each case the polygraph indicated the subject lied. So what they're basically asking here is an and probability. First lied, and the second lied, and the third lied, and the fourth lied. So down here, it's just this times this times this times this. And we get that. Now another way you can do this problem is to just, instead of having the decimals out here or even having the fractions out here, to just do the multiplication in the cell. So make sure you have the equal sign. You have to have the equal sign to be able to do math. But press equals and then just type your fractions in there and multiply them. So I could do 79 out of 126 times 78 out of 125 times 77 out of 124 times 76 out of 123, and then just multiply it like that. Alright, we get the same thing whether we use the cells individually to be the fractions and multiply it, or if we just do all the multiplication in a single cell. Alright, so there's our probability, 0.150 to 3 decimal places, which is what they usually want. Alright, and then it's going to ask, is this unusual? Remember, we're going to use 0.05 to determine if this is unusual or not. And since 0.05 is less than this is a much more probable than a 5% chance. We got a 15% chance here, so we're going to say that's not unusual. Alright, remember, 0.05 is your cutoff. Alright, more notation stuff. B/A, that means the probability event B occurs given that event A occurs. Alright, so that's the notation for conditional or given probability. Alright, back to this table stuff. Again, I'm going to go to this notation, clear it out. If I have a table, more than likely I'm going to need it. Alright, now the table below displays the results from another polygraph test, and we want to find the probability the subject lied given the subject ended up with a negative test result. Alright, compare this result with the probability of selecting a subject with a negative test result given the subject lied, and we want to determine, is it equal if we flip these two things around? Alright, the subject lied was first here, negative test results second. Negative test results first, subject lied second. Alright, we just switched the order around. We want to see if that's equal. So I'm going to, just like I've been doing, complete the table. We need to come up with the total rows and total columns. Alright, and then this is 54 plus 42. Alright, so the first one we're looking at, find the probability the subject lied given negative test result. So probability subject lied given a negative test result. Alright, now this is the given condition. Negative is given to us, so we need to understand that we are working with these 42 people. That's the cell that we're working with. Alright, now given this condition, this negative test result, these 42 people, how many of those 42 actually lied? 9. So 9 is our numerator, 42 is our denominator. Okay, they want 3 decimal places, so 0.214. Alright, always remember it's the second thing, the thing that's after the vertical line, is this is your given condition. So that's how many people that you're dealing with, or how many subjects in the sample you're actually dealing with. Alright, second part says, find the probability a negative test result given the subject lied. A negative test result given that the subject lied. Alright, so now we're no longer dealing with the negative test result. Now we're coming up with a probability that there is a negative test result given that we're dealing with somebody who lied. So now we're in this column. That's our given condition. So there's 52 total people that we're dealing with. And how many of those had a negative test result? 9. So 9 out of 52. So we have two different numbers here, 0.173 for this one. Alright, compare the two values. Are they equal? No. Alright, now, obviously they're just making you look at the two and say that these numbers aren't equal. Alright, yeah, the numbers aren't equal, but what's important that you see is that these two things are not equal. When the first thing and the second thing are switched, we don't end up getting the same thing. Right? Why is that important? Because that means that you're going to be responsible to know when one of these comes before the other, that they're not going to be the same. And because they're not going to be the same, you need to know which one is which. You need to know that the subject lied given the negative test result puts us in this row. The negative test result given that they lied puts us in this column. So you need to be able to understand the notation, especially with the table, and know who you're actually dealing with, which row or column of information you're actually working with in that particular problem. Let's move ahead. At least one probabilities is equivalent to one or more, right? At least one. What numbers are at least one? 1, 2, 3, 4, 5, on and on and on. But it's important that you understand that 1 is at least 1. Alright, at least one probabilities. The only thing that's not satisfied in at least one is none. Right? None and at least one are what we call complements. So when we get to these at least one probabilities, that's conditional. If we get to a at least one probability, we have to understand the easiest way to do it is finding the probability of none and then subtracting that from 1, and we'll get the at least one probability.